Hello, this is John from Military Systems Explained. In the brutal calculus of modern warfare, artillery remains the undisputed king of the battlefield. But right now, one specific system is completely monopolizing the global supply chain. Meet the Hanwha K9 Thunder. Weighing 47 metric tons, or 103,600 pounds. This South Korean tracked platform currently controls over 50% of the world's self-propelled artillery export market. It is not the heaviest, or most heavily armored howitzer in existence. Systems like the German PZH-2000 outweigh it considerably. But the K9 is the undisputed apex of mass production, logistical efficiency, and operational reliability. Powered by a 1,000 horsepower MTU engine, it moves its armored chassis at speeds up to 67 kilometers per hour. While Western defense contractors struggle to scale up, the K9 has ruthlessly become the baseline for Allied forces worldwide. To understand the brutal engineering of the K9 Thunder, you have to look at the environment that forged it. This machine was built under a single, terrifying doctrine: to survive a massive, unannounced artillery barrage from thousands of North Korean guns stationed just across the demilitarized zone, and immediately return fire. This is not theoretical. In November 2010, during the bombardment of Yeonpyeong Island, the system faced its ultimate combat test. When enemy artillery suddenly saturated the South Korean island with high explosives, the stationed K9 batteries took the hit. Despite the chaos and physical damage to their base, the systems functioned exactly as designed. They absorbed the strike, rapidly reoriented, and unleashed a devastating counter-barrage of 80 rounds directly into hostile positions. That ability to immediately return fire under extreme duress is directly linked to the lower half of the hull. The K9 relies on a fully independent hydropneumatic suspension unit, or HSU, mounted on all 6 dual road wheels on each side. A modern 47 metric ton, or 103,000-pound system, firing a 155 millimeter shell, generates immense kinetic recoil. Instead of transferring that violent shockwave into a rigid chassis, the high-pressure nitrogen and oil within the HSU act as a massive dampener. Coupled with an Allison X1100 automatic transmission, and a ground clearance of 410 millimeters, or 16 inches. This kinetic management allows the Thunder to absorb the blast, keep the barrel perfectly aligned for follow-up shots, and instantly throttle its MTU engine to reposition. But speed alone does not guarantee survival in a saturated counter-battery environment. The hull and turret are constructed entirely from POSCO-manufactured MIL-12560H rolled homogeneous armor steel, welded to a maximum thickness of 19 millimeters, or 3/4 of an inch. This specific metallurgical composition is engineered to defeat 14.5 millimeter armor-piercing kinetic penetrators. But the real threat to self-propelled artillery is overhead air bursts. The roof armor is rated to withstand the devastating overpressure wave and high-velocity fragmentation of a 155 millimeter high-explosive shell detonating just 10 meters, or 33 feet away. Internally, the combat compartment is fitted with composite spall liners to catch secondary fragmentation, integrated directly with a collective nuclear, biological, and chemical overpressure system to permanently seal the 5-man crew from contaminated external environments. At the core of the Thunder's lethality is its 155 millimeter L-52 ordnance. This chrome-plated, internally rifled barrel measures over 8 meters, or 26 feet in length, providing the internal volume necessary for maximum propellant expansion. The ballistics are devastating. Using standard M107 high-explosive projectiles, the system reaches 18 kilometers, or 11 miles. With the aerodynamic K307 base bleed rounds, that range extends to 40 kilometers, or 25 miles. For extreme strategic reach, the K315 rocket-assisted projectiles push the envelope to 54 kilometers, or 33 miles. But range is nothing without volume. The K9 is engineered for a burst rate of fire, capable of launching 3 rounds in just 15 seconds. This is achieved through a high-pressure flick rammer system that slams the 90-pound projectiles into the breech at high velocity, ensuring a perfect ballistic seal for every shot. The turret of the K9 is not just a steel box. It is a high-speed ballistic computer integrated with a stabilized firing platform. Central to its accuracy is the Talon 5000 inertial navigation system. Utilizing ring laser gyros, it provides the fire control computer with the vehicle's exact three-dimensional position, heading, and tilt, even in environments where GPS is completely jammed. Instead of manual hand cranks, the 60-degree-per-second turret traverse and elevation are driven by high-torque electric motors. This allows the system to lay onto a new target in under 10 seconds. Inside, the workflow is split for maximum reliability. The machine handles the heavy lifting, automatically ramming the 90-pound shells, while the crew manually loads the powder charges. This system ensures that even at maximum range, the K9 maintains a precision deviation of less than 1%. The K10 ARV is the only system of its kind globally, designed as a robotic extension of the turret's internal magazine. Its internal architecture is centered around a multi-axis robotic shell handling unit. Using optical sensors to identify specific fuse types and propellant loads, this system navigates a honeycomb of 104 projectile racks and 504 modular charges. The telescopic bridge is a pressure-sealed umbilical that synchronizes its conveyor speed with the K9's internal loading mechanism. This robotic link transfers 12 rounds per minute, allowing a full 48-round replenishment in exactly 4 minutes. This automation reduces the crew's physical workload by 70% and maintains full NBC protection throughout the docking sequence, ensuring the battery never has to break its combat seal to reload. Survival in high-intensity artillery duels relies on the muzzle velocity radar, or MVR, mounted directly above the gun mantelet. This radar measures the exact exit velocity of every projectile, feeding real-time data back into the digital ballistic kernel to adjust the elevation for the very next shot. This compensates for barrel wear and propellant temperature variables instantly. Integrated with the C4I network, the K9 receives fire missions via an encrypted tactical data link, allowing a first-round response in just 30 seconds while in motion. While stationary, the Internal Auxiliary Power Unit, or APU, keeps the digital systems and laser gyros active without the main engine. This significantly lowers the vehicle's thermal signature against overhead loitering munitions, allowing the battery to remain in a cold start state until the moment of engagement. The global footprint of the K9 Thunder is not just a market share, it is an industrial massacre. While Western defense contractors spend years handcrafting a few dozen boutique howitzers, South Korea has built an unstoppable manufacturing juggernaut. Today, this single platform commands over 60% of the global tracked artillery export market. To understand this dominance, look at the math. The highly advanced German PZH-2000 took 3 decades to produce roughly 400 units. Hanwha has already forged over 2,000 K9 hulls, and the production lines are running hot. When NATO nations like Poland realized they needed heavy armor immediately to defend their borders, they abandoned European suppliers entirely. They signed contracts for over 600 K9 systems because South Korea is the only country on Earth that can deliver mass mechanized firepower off the shelf. This supremacy is cemented by brutal technology transfers. Egypt signed a $1.7 billion deal to build them domestically, and India established its own active production lines to manufacture the Vajra variant. The K9 did not just enter the international market, it obliterated the competition. The Hanwha K9 Thunder represents the brutal apex of modern mechanized artillery. It perfectly synthesizes the kinetic absorption of its hydropneumatic chassis, the devastating volume of its L-52 ordnance, and the unmatched logistical sustainment of the K-10 robotic resupply vehicle. While competitors chase theoretical perfection in laboratory environments, the Thunder was engineered to survive the most saturated counter-battery fire on Earth and immediately strike back. It is not just a weapon. It is a mass-produced, highly automated siege engine that has forced a complete recalculation of global artillery doctrines. If you want to support the channel and see more deep dives into military engineering, leave a like and subscribe. Next time, we leave the howitzers behind and dissect the M142 HIMARS, breaking down the terrifying mathematics of precision rocket strikes. Until then.